Hello Pre-Calc students, this is Unit 3, Day 4, and today we're going to be using sum and difference identities to find values. So this is a whole new set of identities, and this is not one that you need to memorize, although it can be useful to be familiar with them so you don't have to constantly go back and forth from your identity sheet. So in the first one, we are going to verify this identity, and the left side is the more complicated side. I want you to remember that there is no distributive property for any of the trig functions, so you cannot simply distribute the cotangent to each of these. It just doesn't work. Also, we don't even have a cotangent identity over here, so we have some choices. We could rewrite the cotangent as the cosine over the sine, or we could take the reciprocal of the tangent. I'm going to try doing the cotangent as the cosine over the sine. So this is going to be the cosine of theta minus pi over 2, and that's divided by the sine of theta minus pi over 2. Okay, then I'm going to use one of my identities over here, the cosine of a minus b. So everywhere where I see the a, I'm going to put theta, and everywhere I see the b, I'm going to put pi over 2. So it's going to be cosine theta cosine pi over 2 plus sine theta sine pi over 2. And then I need another identity for the sine. So the sine a minus b is here, and everywhere I see the a, I'm going to put theta, and everywhere I see the b, I'm going to put pi over 2. So it's going to be sine theta cosine pi over 2 minus cosine theta sine pi over 2. All right, and then each time we're going to be bringing down the negative tangent theta. Okay, so cosine of pi over 2, this is actually a value that we know from our unit circle. So thinking about your unit circle, right here is pi over 2, and the coordinates are 0, 1. So the cosine is the x value, the cosine is going to be 0. So I have cosine theta times 0 plus sine theta, and the sine of pi over 2 is the y value, so that's the 1, so times 1. And then on the denominator, I have sine theta times the cosine of pi over 2, which is still 0, minus cosine theta, and the sine of pi over 2 is 1. So 0 times cosine, that's going to cancel. Sine times 0 is also going to cancel. And I have a sine over a negative cosine. So let me just write that simplified value. Sine theta. And I'm going to bring the negative out front right here, just so I can see things more clearly. But this is the negative that I'm bringing out front. All right, so these both equal negative tan theta. And then you can remember from your quotient identities that sine over cosine is tangent. So you finally get negative tan theta equals negative tan theta. Okay, problem 3 is a simpler version of this one because it starts with just a cosine. So let me change color so I don't lose track of what's what. And this is going to be a cosine of a minus b. So everywhere it has an a, I'm going to put theta, and everywhere it has b, I'm going to put pi over 2. And actually that's the same thing as I had written here before. Theta is a, pi over 2 is the b. So I'm going to have cosine theta cosine pi over 2 plus sine theta sine pi over 2, and that's going to equal sine theta. I'm kind of running out of room. Let's see if I can drag this over. Okay, so this equals sine theta. All right, so again, I know that the cosine of pi over 2 is 0, so it's going to be cosine theta times 0 plus sine theta, and the sine of pi over 2 is 1 times 1 equals sine theta, and this is 0. So basically, we're done. Sine theta equals sine theta. Check. Okay, moving on. All right, so now we have some expressions that look like the right side of our identities. So if you look at this, it has sine, cosine, plus cosine, sine. So I'm looking for sine, cosine, plus cosine, sine. That's this first one here. So if I line that up, it's sine A, cosine B, plus cosine A, sine B, equals this side, the sine A plus B. So that means all of this can be simplified to be this, the sine of A plus B. And in this case, my A is 10 degrees and my B is 80 degrees. So I can add 10 and 80 and I get the sine of 90 degrees, which is actually the same, of course, as pi over 2. So it's the same point we've been talking about right here. And the sine is the y value, which is 1. So my final answer is 1. Okay, and number 19. I have sine A cosine B minus cosine A sine B. Sine A cosine B minus cosine A sine B. So that looks like the second one. So this is my A, B, A, B. So this time it's the sine of A minus B, which is the sine of 310 degrees minus 130 degrees, which is the sine of 180 degrees. So thinking about our circle, we're over here, and this point is negative 1, 0, the sine being the y value, so your final answer is 0. Okay, so now I have the sine of 15 degrees, which is not on my unit circle. But I could express that 15 degrees as 45 degrees minus 30 degrees. There are actually a lot of different ways you could express it, but that's one of the simplest ones. So I'm going to write this as sine 45 degrees minus 30 degrees. Now I can't distribute the sign, that just doesn't work, it won't give me the right answer. But what I can do is turn over here to sine A minus B. So that means that my A is 45 and my B is 30. So everywhere I see A, I put 45, and everywhere I see B, I put 30. So that's going to be sine 45 cosine 30 minus cosine 45 sine 30. Okay, and then you need to remember from your unit circle, first quadrant, at 30 you have root 3 over 2, 1/2, and at 45 you have root 2 over 2, root 2 over 2. So sine of 45 is root 2 over 2. Cosine of 30, that's going to be the x value, so that's root 3 over 2. Cosine of 45, that's the x value again, root 2 over 2. And sine of 30, that's the y value, that's 1/2. So using order of operations, I'm going to multiply first. I get root 6 over 4 minus root 2 over 4. And because I have a common denominator, I can combine these into one fraction. Root 6 minus root 2 all over 4. Okay, so for cosine 255 degrees, there are a lot of different choices. You want to try adding and subtracting a few different things until you find one that works. I'm going to try cosine of 210 degrees plus 45 degrees. So in the cosine A plus B, 210 is my A and 45 is my B. So I have cosine 210, cosine 45, minus sine 210, sine 45. All right, so 45 is already on this circle. 210 is over here, and the coordinates for 210 would be negative root 3 over 2, negative 1/2. So cosine of 210 is negative root 3 over 2. Cosine 45 is root 2 over 2. Sine of 210 is negative 1/2, and sine of 45 is root 2 over 2. All right, so here I get negative root 6 over 4, and negative negative makes positive, root 2 over 4, and you can combine that into one fraction, negative root 6 plus root 2 over 4. If you used a different combination of numbers to make your 255, that's okay, but your answer should be equivalent to mine. Okay, I'm going to do tangent of 75 degrees. So I need tangent of 30 plus 45. And I'm going to put this over here. So this is my 30 and this is my 45. So my formula says tan 30 plus tan 45 over 1 minus tan 30, tan 45. Okay, so 30 degrees, remember, was root 3 over 2, comma 1/2. And 45 degrees is root 2 over 2, root 2 over 2. And tangent is y over x. So when we're finding these values, we need to remember all of that. Tangent of 30 is 1/2 divided by root 3 over 2, which simplifies to root 3 over 3. So I have root 3 over 3 plus tangent of 45 is root 2 over 2 divided by root 2 over 2, which is 1. Denominator is 1 minus root 3 over 3 times 1. Okay, so I need to combine these two with a common denominator, and I need to combine these two with a common denominator. So I'm going to multiply this 1 by 3 over 3, and I'm going to multiply this 1 by 3 over 3 so that I can combine. So on the numerator, I get root 3 plus 3 over 3. And in the denominator, I get 3 minus root 3 over 3. Okay, so when you have a fraction divided by a fraction, you can keep the first fraction, root 3 plus 3 over 3, and flip the second fraction and change to multiplying. So then you can see these 3's will cancel out and give you an answer of root 3 plus 3 over 3 minus root 3. Now, for some purposes, teachers may let you stop right here, but you do have a radical in your denominator, which is an issue. So to get rid of the radical in the denominator, your strategy is to multiply by the conjugate. So remember, the conjugate of a minus b is always a plus b. And we're going to multiply by the conjugate of the denominator because that's the one that we're not allowed to have. We're not allowed to have the square root in the denominator. So let me take the original, root 3 plus 3, 3 minus root 3, and multiply by 3 plus root 3. That's the conjugate of the denominator. In the denominator, you have 3 times 3, which is 9. And then you have a positive 3 root 3 and a negative 3 root 3, which cancel out. And then you have a negative root 3 times root 3, which is just 3. In the numerator, you have 3 root 3. Root 3 times root 3 gives you 3. 3 times 3 gives you 9. And then another 3 root 3. Okay, combined like terms, I have 12 plus 6 root 3 over 6, which simplifies to 2, plus root 3, and that is your best answer. Okay, to do sine of negative 75, we're going to need to subtract two numbers that will have a difference of negative 75. So let's see, we need a 45 in there somewhere. So let's try something like sine 45 minus 120. So that should give me the negative 75. So 120 is still over here, and it still has coordinates negative root 3 over 2, negative 1/2. Okay, so 45 is my A. So A minus B, 45 is my A, and 120 is my B. So I'm going to have sine 45 cosine 120 minus cosine 45 sine 120. So sine 45 is root 2 over 2. Cosine 120 is the x value, negative root 3 over 2. And minus cosine 45, root 2 over 2. And sine 120 is the y value, negative 1/2. So I get negative root 6 over 4. Negative times negative turns positive, root 2 over 4. And that combines to give you negative root 6 plus root 2 all over 4. Okay, in number 33, there's a hint here, multiply by the conjugate. Now, if you're looking at your homework, this actually only helps in number 33. Multiply by the conjugate doesn't actually help with number 34. So in number 34, I would use the strategy of getting everything in terms of sine and cosine. Okay, so multiply by the conjugate, let's just use the right side, and let's multiply by 1 minus cos theta. So the left side stays the same. We're going to keep the numerator factored, sine theta times 1 minus cos theta. And then in the denominator, I have difference of squares so that when I multiply it, my middle terms will cancel out. So 1 times 1 is 1, and then I have a negative cosine and a positive cosine, which cancel out, and then I have a negative cos squared theta. So I can replace the 1 with sine squared plus cos squared. Oops, I dropped a theta there. Okay, so copy my numerator and replace the 1 with sine squared theta plus cos squared theta and minus the cos squared theta. So these two will cancel. And now I have sine over sine squared, which using exponent rules, when you subtract the exponent, gives you just a sine theta in the denominator. So this should give us our final step. 1 minus cos theta over sine theta equals 1 minus cos theta over sine theta. In 37, it says, explain how you can use this identity to simplify the cosine of negative theta. Well, you can do that if you think of your A value as 0 and your B value as theta. So we would be doing cosine of 0 minus theta, and we would put that here, 0 minus theta, so that you could substitute in. So it would be cosine 0 cosine theta, and then plus sine 0 sine theta. So thinking of your unit circle, the point here at 0 degrees is going to be 1, 0. So the cosine of 0 is 1, so that would be 1 times cosine theta, plus the sine of 0 is the y value, 0, 0 times sine theta. So 0 times sine theta cancels out, and 1 times cosine theta is cosine theta. So this equals cosine theta, which means that the cosine of negative theta is equal to the cosine of theta. And whenever this is true, whenever you can input the opposite into a function and get the same result, this is called an even function. Okay, we have one last problem. This problem is talking about two different angles. One angle is named alpha, and one angle is named beta. So we're going to try to see if we can use a different color for each one. We're going to do a story about alpha. and another story about beta. Okay, so alpha has a tangent of -3/4, and it's between pi over 2 and pi. So we're going to draw, here's pi over 2, and here's pi. So the angle's somewhere in here. And it has a tangent of -3/4, so I'm tempted to put -3 here on the opposite and 4 on the adjacent. But then this shouldn't be negative, it's this one that should be negative. So you can switch things, make this the 3 and this the -4, and then alpha still has a tangent of -3/4 when you divide those numbers. All right, and then here's beta. Let's switch over. So beta is between pi and 3 pi over 2. And it's over here. So the cosine is adjacent, -5, over hypotenuse, 13. So to find the tangent of alpha minus beta, I need to use this formula here, which has tangent A and tangent B in it. So I already know the tangent of alpha, but I don't know the tangent of beta, so I'm going to have to do some Pythagorean theorem to figure this out. So I have -5 squared plus y squared equals 13 squared, and 25 plus y squared equals 169. Y squared equals 144, and when you solve with a square root, remember that y could equal plus or minus 12. So looking at the picture, you can see in the third quadrant the y has to be negative, so it's going to be a -12. So now we can do tangent of alpha minus beta. I'm using this formula right here, and I'm going to substitute in. So tangent of alpha minus tangent of beta over 1 plus tan alpha tan beta. Tangent of alpha is -3/4. We were actually told that in the beginning. So -3/4 minus tangent of beta is -12. Oh, here's beta here. -12 over -5, and the negatives cancel, so that's just 12/5. Then I have 1 plus tangent alpha tangent beta. So now I just need to simplify. If I look at the numerator, I need a common denominator, so I'm going to multiply this fraction by 5 over 5, and this fraction by 4 over 4, so that I can have a common denominator of 20. And down here I have a denominator of 20, so I need to multiply this one by 20 over 20. So in my numerator, I have over 20, -15 minus 48. In my denominator, I have 20 minus 36 over 20. So combining these two, I get -58, -63 over 20. And combining these two, I get -16 over 20. So I have -63 over 20 times 20 over -16. The 20s cancel, the negatives cancel, and I get 63 over 16.